Hello, and welcome for joining us today on this presentation on connected construction. My name is Ahmed Abdelmegid. I'm the Regional Sales Engineer for the MEP and GC products. And today I'm joined by my colleague Mohammed Al-Azraq, who's the Regional Sales Engineer for the Structures Solutions. The topic of this presentation will be about connected construction and how it applies to different disciplines such as MEP, project management, and structures using Trimble products and specifically Trimble Connect in order to connect different stakeholders and processes on your projects. We'll start first with connected MEP. And I'd like to shed some light on one of our products called Trimble SysQ, which is a platform that runs on top of Revit, and it allows detailers to design data-rich LOD 400 MEP models that are ready for fabrication, procurement, and installation. It's powered by a powerful content library from more than 630 manufacturers and millions of objects. So this is an overview of Trimble SysQ. And as you can see, it allows you to model all the different trades, including pipes, conduits, ladder trays, and all kinds of cable trays, HVAC ducts, and many other components. Now, with SysQ, you're able to take a generic model and convert it into a manufacturer-specific model. So you can see I've selected an entire run of pipes, and then I select a specific manufacturer I would like to work with, and with a click of a button, I can convert this generic model into a manufacturer-specific model. And that way, all the parts will be replaced with their corresponding fittings from that specific manufacturer, and also all the long segments will be cut into the standard cut length. So if I select any of those fittings and I go to its properties, I can see the catalog associated with that fitting already embedded as an attribute on the element. That's part of the standard SysQ functionality. What I can also do is add supports and hangers for that run. So you can see with a click of a button, I've defined the settings for my supports, the spacings for them, where they need to go, and automatically SysQ will place the supports for me. They are intelligent enough to look for the nearest structural element and fix there. And you can see that this support found a structural beam as the nearest element, and it attached itself to that beam over there. So this is SysQ as it works out of the box. Now, how can we use SysQ along with Trimble Connect in order to connect different stakeholders on the project and let them leverage this data-rich model? So one use case is ad hoc reporting for managers who might not be using SysQ, but would still want to take a look at the model. And in this scenario, one of the manufacturers is facing production issues, and the management would like to identify the areas at risk of delay and quantify the impacted elements. So when the model is published from SysQ to Trimble Connect, now you can see all the elements are visible, including the structural model done in Tekla and the MEP model done with SysQ, and they are visible in the web browser of Trimble Connect without the need to have any other application installed. And from the organizer of Trimble Connect, the user can select that specific manufacturer, and they can see which items they are producing for that project. So now I can get an idea that ABI provides sanitary and vent pipes for that project, and these are all the associated elements. Now I can filter down further and select only the pipes from the object type in the organizer. And from the system classification, I will select vent pipes. So now I've narrowed down my search, and now I can take a look at all the vent pipes, understand where they are in the project, and get an idea of what the impact will be because of the production problems the manufacturer is facing. And once I'm done, I can export all that element to a CSV file. So as you can see, someone who's not using a BIM authoring platform can still leverage the data-rich information using Trimble Connect. Now, another use case is also to use Trimble Connect to provide the owner with a digital operation and maintenance data set that they can use. And once again, since the MEP assets are already tagged with hyperlinks to the catalogs, and that was done by Sysq, the information is already embedded in Trimble Connect, and they can use this easy platform to access all the information they need. Plus, they can also manually add some operation and maintenance manuals to the equipment. So if we take a look at this video, you can see that the model is already there. And if I select any element that was authored in Sysq, all the attributes that came with the authoring platform are already visible in Connect, as well as a hyperlink for the catalog for that item. So that way the owners and the facility managers, once they receive the full data set, they can access that information very quickly. Additionally, if something wasn't modeled by Sysq, so let's say this air handling unit, using Trimble Connect, I can attach the operation and maintenance manual for it. So I can put that document on Trimble Connect and link it to that model object. So that way the end user from the client and the facilities manager, at any point they can select that element and select the document that's associated with it, and have access to that document at any point in time. So as you can see, Trimble Connect is able to integrate different processes and also different teams, not only during the construction phase, but also during the handover and operation phase of the facility. The other topic I would like to discuss is connected project management. And in this exercise, I would like to show an example of how the cost control process can be model-driven, also using Trimble technologies, including Trimble Connect. We can see how the processes for inspections and sign-off can be streamlined and connected between the different teams. And you can also see how we can extract accurate reports of the completed works for invoicing purposes. So for project management, Trimble has many solutions under this domain. One of the solutions is called Project Site. So this is your document control and project management solution. It's also integrated with Trimble Connect, as well as Tekla Structures, of course, is also integrated with Trimble Connect. And with Trimble Connect sitting in the middle, you can see a full connected construction cycle between different stakeholders. So in this scenario, we have multiple stakeholders. We have the consultant, and we have the general contractor with project controls team and the commercial team, and we have the MEP subcontractor. And in this scenario, we will demonstrate how the different teams using different technologies from Trimble are all connected. And in this scenario, the MEP subcontractor has just completed one zone in the project, and they would like to send an invoice, and the general contractor would like to verify the quantities on that invoice. So this is how the process would work. The project controls team will initiate a request for inspection on project site. The teams will be notified from the consultant team, and they can go ahead on site with their mobile devices and start doing the inspection on the 3D model. So now the consultant has to approve and sign off on the elements that have been installed using Trimble Connect. And this is how the process would look like. So if I increase the quality, you can see the consultant is using the mobile device here on the right. They go to the BIM model, select the elements, and say completed for the task of the consultant sign-off. Now, obviously, that's using the status sharing application of Trimble Connect, which also works on Trimble Connect Mobile. And the advantage here is that within a few seconds, the users using other interfaces of Trimble Connect, such as the Windows interface, will be looking at the same model, and within a few seconds, those elements will reflect in green, showing that they have been signed off. So that makes sure that all the teams are synchronized and they are all looking at the latest status of the model. Now, after that process, and the consultant has signed off on the elements, the MEP contractor can proceed with creating an invoice, again, on project site. And the next step will be for the general contractor to verify the quantities on those invoices. So they need to open the BIM model and verify if those items have actually been signed off and to make sure they haven't been invoiced before. And for that, Tekla structures can be used. So as you're all aware, Tekla structures has a very powerful organizer tool, which we can leverage for this process. I've imported the MEP model as IFC into Tekla structures. So now I can see all disciplines combined within Tekla structures, and I can categorize the elements using the organizer. So it already reads the attributes that came on the IFC elements, and now I can switch between the different types of elements and select them from my organizer very quickly, even though they are not native Tekla elements, but were rather imported as IFC elements. I can also look at different locations within the building, so I can filter only the west wing for the project, or a certain floor within the west wing. And then including to that, I can also do some cross filtering. So I can look at floor 2 and only the ducts and duct installations for that project in that zone. And as you can see, the cross highlight and cross filtering works very quickly within the Tekla structures organizer. So I can also have multiple categories. So I can create categories for the items that have been signed off by the consultant and the ones that are still pending. So this way I can have a clearer picture of which items can be invoiced and which items are not. And I can also create categories for the items that have already been invoiced, so we make sure that nothing is double counted. So using this organizer, what the team can do in Tekla structures is look at all the items that have been signed off by the consultant and have not been invoiced yet. And these are the only elements that could be added in the next invoice. And from here, I can narrow down further and select only the mechanical elements, for example. And based on all this selection, I can filter the elements in the model that match these criteria. So these are the mechanical elements that are approved and haven't been invoiced yet. I can isolate them to make sure they are working properly. And I can also visualize this in context of the structural model, just to make sure that I have the elements in the correct location. And now I can see those specific MEP elements in context with the structural model as well. And based on that information, I can save this as a sort of a selection set and make it easier for the other teams to work with. So I can select all these elements, and again, using the status sharing tool of Trimble Connect, I can assign them to invoice number 2. And based on that, all these elements have been attached to that invoice. And this would allow me then to save this as a filtered view in Trimble Connect and make it easier for the other teams to access just that information. So for example, as you can see in this video, now I will use Trimble Connect. And based on the items that are related to invoice number 2 using status sharing, I can use Trimble Connect to isolate those elements and create a 3D view for just those elements. That makes it easier for the team, so they don't have to navigate an entire model, and I'm creating a view for them on Connect with the name of invoice number 2. And it makes it easier even for other teams who may not be very familiar with BIM platforms to access that information very quickly. So once the project controls team save a filtered view in Trimble Connect, they can create an action item on project site for the commercial team to look at the invoice and look at the elements that were isolated in the 3D model and cross-check and make sure that the invoice is only reflecting those items. So this is how it would look like in project site. Under the action items, you can see there's an existing one for invoice number 1. And now we're creating a new action item for verifying the invoice quantities of invoice number 2. And from here, I will ask the team to verify the invoiced quantities by the MEP subcontractor for invoice number 2, and I will assign it to the correct team. And within that action item, I will put 2 attachments. So I will put the invoice itself, which is already saved on project site, and I will save the 3D view from Trimble Connect. So project site will show you all the views that you have already saved on Trimble Connect, and you can choose the correct view. In this case, it's invoice number 2, and also attach it to the action item. So that way, the QS team will have an action item with all the information there ready for them to start doing the review. And the final step will be for the commercial team to open project site, look at this action item, look at the invoice and the model elements, and verify the invoiced quantity. So the process would look like this in project site. They would go to the action item, filter the open and pending ones, so it's related to invoice number 2, and they can see the details of the action item as well as the attachments that are added to that action item. So if they go to the attachments tab, they can see there's an invoice and there's a model view as well. They can open the model view directly, and project site will open it in Connect, and they can check the details of the invoice. Now, these are all the line items in the invoice for the items that have been supplied and installed by the contractor. And they can see there's a 1-inch diameter pipe, and this invoice is for 5.2 meters of pipes. So they want to open the model and go to the view of invoice number 2 and check those pipes, find them in the model, and verify that this quantity is correct and it has been signed off by the consultant. So using the data table of Trimble Connect, this is what the team will be able to report on. So at first, Trimble Connect is asking the user to select the objects so that it can report the attributes that are attached to those objects. And based on that, we can narrow down and find those specific pipes. Now, I've created multiple report templates, and one of them is a report for pipe length, showing only these columns I'm interested in. And if I select everything that was saved for me in the view, I can see all the details, whether they are pipes or ducts or accessories. And I can very easily group them by object type. And then if I go to the pipe category, I can select them in 3D, and that's showing me all the pipes and the model, and that would allow me to isolate them quickly. Now, I'll group by classification as well, and also by size. So that makes me able to drill down very quickly to the pipes of domestic cold water under 1 inch, and the system automatically gives me a sum of 5.2 meters, just like it was in the invoice. And I can isolate that in the 3D model as well to make sure that the invoiced quantity matches what we have in the model as well. And then from here, I can enter my comment and say that the quantities have been verified by the team. So this way you can see that with Trimble Connect in the middle between different Trimble technologies, you can connect multiple stakeholders on the project and make sure that everyone is on the same page. So this concludes my section on the presentation. And now I will leave the stage to my colleague Mohammed Al-Azraq to walk you through connected structures. Thank you very much.
Thank you very much, Ahmed. It's really a great session. And actually, me myself learned a lot from you today. So my name is Mohammed Al-Azraq. I'm solution specialist here in Trimble. And today I'll be talking about connected structures. And in particular, I'll be talking about the concept being to field. So all of us know that tackless structures is really that constructible model. We got a lot of data, a lot of information. Everything is there in the model: bolts, welds, reinforcements, embeds. All the little details are there in the tackless structures model. So what we're trying to promote here is those information, or this information, we want to use them there on site. We don't want them only here in the Tekla model and that's it. We want everyone involved in the project to benefit from this data. So the concept is you grab the data from Tekla structures model and you use them in the construction in terms of positioning or laying out the point that's really needed for the erection or for even for the fabrication. So we're linking the data with the robotic total station. So how it works, or what is really required from you to do extra in Tekla structure is actually not much. You just need to export the IFC data from Tekla structures, and also you need to highlight these points that you really want to lay out on the site or in your fabrication yards. And it's actually needed even in the fabrication, because sometimes you have a very complex assemblies, very curved structures with little welds here and there. So doing them manually or using a traditional total station is not really going to help much. But with this technology, the robotic total station will be able to identify the exact position where you have to weld your stiffener or your secondary member, let's say, for example. Right, so let's dig deeper and see how or what is really required. As I mentioned earlier, a simple IFC out of Tekla project, and the second thing is we need to identify these layout points that we want to mark them on site or on the fabrication yard. And the last thing is just to export these layout points or coordinates to there. So how it works, I have a small video here we can have a look at. This is how it's done. Actually, we have this layout point already in Tekla by default. It's the standard tool to place a layout point, and this one is to position a single layout point for a particular location, let's say for a critical point, for a bracing start, bracing end, or so you have some curved structure or complex structure. This way you can identify specific points. If you want to do it like in mass scale, let's say I want to have it for all of my anchor bolts, or let's say foundation edges, then for that we use the layout point applicator. It's very simple because it's based on specific filters, and here we're filtering for the anchor bolts. We'll find them, then position this layout point on top of each anchor bolt, for example, and also we tried also again for the foundations corners. Then the next thing we can do is to export the coordinates for these layout points, and for that you have the choice if you want to use the model coordinate, or if you have a specific base point. Let's say base point that represent the global coordinate, or your site coordinate, or maybe your fabrication yard coordinate. That all you can control and you can decide. You can see from here you can select a specific base point, and then you immediately see and feel that the coordinate reflects the new base point. Eventually what we can do is to run this export functionality. We have a unique export file format. We call it .tfl, and this is it. We can then select the file and run the export. Then after it we grab this file and we feed it to a specific software that we have, and that software is the Trimble field link. It will read the .tfl file format, and it will read the IFC file, and then you will visually see the Tekla model. You will see the coordinates and see everything coming coordinated together. And this Trimble field link, it runs on a tablet because you need that on your site to see everything, to be able to view and check everything. The software, the Trimble field link, it can read the IFC file, PDF, of course, drawing, that all can be read. And also you can do like the sections, view data, and also run reports. A bit more about like in terms of managing the data, you can import from CAD, you can make sections, create views, view like object information, all this stuff you really can get from this software. Right, so this is a quick video showing you how it works or behave on site. So basically, let me run that. We'll walk you through it to show you how things are being done. This is actually the robotic total station. You need first, of course, to position it on your site or on in your fabrication yard, and then with the help of a specific prism, you'll grab that prism, and the total station, or the robotic total station, will highlight that particular point, which we defined already before using the layout point. You'll grab the prism, go there to find this highlighted point. Once you reach it, the software will tell you, are you there yet, or you need to move a bit to the right, to the left, to the right, till you reach the exact point. As you can see here, he's trying to reach that point, and the moment he's going closer to it, the system will finally or eventually tell you, yeah, you reached, and you can mark that particular point. And this is as simple as it is. This is how it works. You don't need to do any manual measurement, any manual guessing anymore. Right, what else you can get? You can of course get reports, data from it, because we're capturing what you saw, and we can get it in a report. You can get deviation reports, daily reports, progress reports, all this stuff you can generate. So yeah, Thank you a lot for your time. This was just an introduction for the BIM to field technology that we have here in Trimble. If you need more information about how it works, full detailed demo, if you want to see the device live, we're happy to show you more about it. Thank you for your time, and we'll see you in the next session. Have a great day.